Look at the planet from space. Cloud systems moving, oceans shifting, ice sheets changing. The Earth generates massive amounts of data every second. The challenge isn't lack of information, it's understanding patterns. That's where AI enters. Artificial intelligence doesn't create climate change models from nothing. It analyzes enormous data sets faster and more efficiently than traditional methods. Let's break this down. Satellites collect data on temperature, rainfall, ocean heat, and vegetation. Weather stations record local conditions. Ocean sensors track currents and salinity. This creates petabytes of data. AI systems learn from that data. They identify patterns. They detect anomalies. They refine predictions. This approach builds on decades of climate modeling pioneered by scientists like Shukuro Manabe, who developed early numerical models linking carbon dioxide to temperature change. His work laid the foundation for modern climate simulations. Now zoom in. Traditional climate models rely on physical equations. AI enhances them. Machine learning can improve short-term weather forecasting, refine long-term temperature projections, predict extreme events like floods and heat waves, analyze deforestation and land use change. It doesn't replace physics, it accelerates insight. Now zoom out. Climate prediction isn't just scientific curiosity. It affects insurance pricing, agricultural planning, energy demand forecasting, infrastructure design, disaster preparedness. If heat waves increase, energy grids must adapt. If rainfall patterns shift, water systems must adjust. If storms intensify, cities must redesign defenses. This is why AI-powered climate analysis is now integrated into global planning. Organizations like the United Nations, supported by scientific bodies such as the Intergovernmental Panel on Climate Change, rely on advanced modeling and data systems to evaluate future risk scenarios. AI helps refine those scenarios. But here's the important distinction. AI does not decide policy, it informs it. Predictions are tools, decisions remain human. Now here's the key insight. Climate systems are complex. Small changes cascade. AI is powerful because it can detect subtle signals early before damage becomes visible. Before we end, zoom out one last time. AI teaches a modern lesson. Data alone is noise. Pattern recognition creates foresight. Environmental science now combines physics, ecology, and machine learning because managing planetary risk requires both natural understanding and computational power. In the next episode, we'll explore machine learning and disaster prediction, where we'll see how AI helps forecast floods, wildfires, and extreme weather events in real time. This series is part of the Learning Studio, where environmental science meets technology, policy, and real-world systems. This isn't about replacing scientists. This is about strengthening decision-making.